Hello everyone. The topic of my capstone project is on the feasibility study of renewable energy, power generation using solar PV geomembrane technology at an abandoned mine tailing site in Cape Breton, Nova Scotia. The research question for my study is, can abandoned mine tailing sites be used as solar PV farms? This project was sponsored by CEDA Inc. and Mitex under the Business Strategy Internship Program. Commercial mining activities in the province of Nova Scotia have resulted in abandoned tailing sites over the years that contain significant concentrations of toxic substances that pose serious social and environmental problems. Contaminated tailing ponds have resulted in the deaths of wildlife and migratory birds landing on these sites. Seepage losses from these tailing sites have caused elevated levels of toxic chemicals in nearby water bodies, leading to contamination of the water supply. The burning of coal-generated fuels for electricity generation has resulted in emissions of greenhouse gases, causing air pollution and adverse health impacts. The research study would provide an alternate solution to remediation of mine tailing sites to produce green, renewable energy and reduce the dependency on coal-generated electricity, hence reducing greenhouse gas emissions. The Victoria Junction Tailings Dam, located in Cape Breton, Nova Scotia, was selected as a site for this study. The tailings basin is located about 3 kilometers east of Sydney, and the size of the tailings pond is approximately half square kilometers, or about 143 acres. There are approximately 1 million cubic meters of tailings currently under subaqueous containment in a pond behind an earth-filled dam. Just 500 meters north of the pond is Kilkenny Lake, which is a secondary water source for New Waterford. The scope of the research study includes a techno-economic assessment of a solar PV facility installed on the dry tailings site with an assumption that water has been removed from the pond and the tailings have been solidified and stabilized. The first step of the study was the energy demand assessment, and for this study I have selected the town of New Waterford for the electricity consumption analysis. The next step is determining the solar radiation potential of the tailings site, followed by the PV system selection and system production analysis. After the sizing of the solar PV facility was determined, an economic assessment was conducted. The final step was the analysis of greenhouse gas reductions by comparing 3 different site remediation methods. The area solar radiation tool in ArcGIS calculates radiation based on the position of the sun throughout the year. The effects of shadows on the PV system was assessed using a conservative evaluation method by analyzing the daily sunshine hours during the winter months. In order to identify suitable areas for PV installation, the following criteria was set up as filters in ArcGIS to eliminate all surfaces with slopes greater than 5.71 degrees, solar radiation less than 800 kWh per meter square, and all surfaces facing north. The analysis shows that 227,000 square meter or 56 acres of land with an average solar radiation of 1056 kWh per meter square is suitable for PV installation. The total annual electricity demand for the community of New Waterford is 45 million kWh per year based on 3,520 households. A solar PV system is to be designed to meet 25% of the total annual electricity demand, which is 11.1 million kWh per year or 14.3 megawatts. Therefore, a solar PV system was designed for a 15 megawatt capacity. The solar PV array selected is a SunPower Maxion SPR A450 watt model. The total number of modules required is 33,600 with 14 modules per string and 1,200 strings arranged in 2 sub-array layout configuration. The inverter selected is the Canadian Solar CSI 25K T400 model, which has a 98.8% conversion efficiency, suitable for commercial utility applications. 590 inverter units are required to support the 15 megawatt PV system. There are 3 remediation methods proposed for this project. Option number 1 consists of solar PV modules with partial geomembrane cover, topsoil and vegetation at the surface. Option number 2 consists of solar PV modules with geomembrane cover for the entire tailings site. And option number 3 is the traditional remediation method with topsoil and vegetation throughout the site with no energy production. The solar PV geomembrane remediation method consists of PV modules mounted on ballasted supports. A layer of high-density polyethylene, geomembrane, and geosynthetic clay liner are installed at the surface to act as an impervious cover layer, preventing water from percolating through the soil to the tailings. A geotextile separator is placed on top of the tailings, below the bedding soil to serve as a protection cover against soil contamination. The traditional remediation consists of topsoil and vegetation at the surface with a geocomposite drainage layer below the protective soil cover. A geomembrane clay liner and a geotextile separator are placed on top of the tailings. The drainage layer selected has high load-bearing capacity and hydraulic conductivity properties to divert the flow of water away from tailings. The research concluded that energy power generation from the Victoria Junction coal mine tailings site using solar PV geomembrane technology is technically and economically feasible. The total electrical energy production that can be generated from the solar PV facility is 15 megawatts or 15,845 megawatt hour per year. The analysis revealed that the annual reduction of greenhouse gas emissions by installing a solar PV system is significantly greater than the forest restoration alone. Although the greenhouse gas reduction potential and the total annual revenues for both option number 1 and 2 are similar, option number 1 is the most cost-effective method than option number 2. Option number 3 does not produce any electricity from the site and therefore does not generate any revenue. Comparison of the economics and amount of greenhouse gas emissions reductions indicated that option number 1 would be the recommended remediation method. Based on a structural integrity assessment, the site has sufficient load-bearing capacity to support the solar PV system. Some limitations encountered for this project were that the monthly consumption data for New Waterford were not readily available and had to be interpolated from the provincial load data. Solar radiation data from ArcGIS cannot be imported into SAM. Therefore, the shading analysis had to be done separately in ArcGIS and then manually entered into SAM to calculate suitable area for PV installation. Recommendations for future work include looking at the feasibility of using 1. A floating PV system, number 2. A laminated PV geomembrane system, number 3. Water drainage and pumping facilities, and number 4. Zoning, permitting, and environmental regulations. This comes to the end of my presentation. Thank you for listening, and I'll be happy to answer any questions you may have.